Is Korea ready for quantum computing? That and more on Korea Technology Weekly. Hi, I'm your host, Dr. J.R. Reagan. In this episode, we'll be discussing South Korea's plans to become a leader in quantum cryptography and computing. The South Korean government joined the race of next-generation technology developments, including core quantum computing technology, by investing 44.5 billion Korean won, which is about 39.8 million US dollars, beginning in 2019 over the next 5 years, which will significantly enhance the computational performance and security of computers using quantum mechanics principles. The new quantum computing technology development project aims to secure core technologies of quantum computers, which are actively explored and developed for practical applications worldwide. Over the next 5 years, the project will invest in the development of core technologies like quantum computer hardware and in future promising areas, such as quantum computing new architecture, quantum algorithms, and base software. Through the development of key technologies for quantum computing, the government plans to develop demonstration of the practical 5-qubit or qubit information unit quantum computer system with more than 90% reliability by 2023. In addition, the government will use state money of 13.4 billion Korean won, which is about 12 million US dollars, to support the development of key proprietary technologies in 4 areas, including system software, software engineering, information and intelligence systems, and human-computer interaction, or HCI, through the Next Generation Information Computing Technology Development Project in the field of software and computing. Korea also aims to take the lead in standardization of quantum cryptography. The National Radio Research Agency in South Korea announced that the ITU-T Study Group 17, or SG-17, has adopted 8 security-related proposals prepared by South Korea as international standards, while at the same time establishing a task group dedicated to the development of standards for quantum cryptography. SG-17 is a study group under the ITU-T that focuses on establishing and revising communications security standards. The 8 proposals were developed jointly by academia, industry, and government, including the Finance Security Institute, Korea University, Soonchunhyang University, SK Telecom, Kakao Mobility, the Korea Internet and Security Agency, or KISA, the Electronics and Telecommunications Research Institute, or ETRI, Korea Information Systems Consulting and Audit, and Hyundai Motor. At the SG-17 meeting, 6 proposals related to quantum cryptography, blockchain, and vehicle security were adopted, and 2 proposals on personal information protection and cybersecurity failure response were adopted as final standards. Among those adopted were standards on security frameworks for quantum cryptography key and distribution networks, quantum cryptography keys, and security key supply. These standards define how cryptographic keys generated by the distribution technology are combined with encryption keys along with elements that make up the network where quantum keys are transmitted, and a communication environment and security requirements. This enables connections between existing and quantum cryptographic communication networks, which can lower construction costs and speed up introduction. In addition, technical terminology of blockchain and standards on guarantee of corresponding security provide criteria on determining security level of blockchains. This will be used as a guideline for companies that provide blockchains to check security levels of its own systems. Standards on security requirements for external access devices and in-vehicle network intrusion detection systems are expected to contribute to the spread of related services by strengthening the security of self-driving cars and securing interoperability among automakers. Additionally, standards on de-identification framework provide procedures to de-identify personal information and technology to safely handle target data, while it provides guidance to determine the suitability and reliability of technology used to collect and preserve evidence data in the event of a cyber breach. Industry is also jumping into quantum cryptography. With the growing demand for tighter computer security, South Korea's 3 telecom companies, which are SK Telecom, KT, and LGU+, are quickly expanding the application of quantum cryptography technologies into more industries to provide protection against quantum cyber attacks. Quantum cryptography, currently used mainly to protect smartphone devices and mobile apps, is projected to be more widely used in financial transactions, medical data protection, and smart cities, as well as smart factories. SK Telecom, the country's largest mobile carrier, has been the most aggressive. The company started investing in quantum cryptography technologies from 2011 through 2018 and acquired the Swiss-based leader in quantum safe security solutions, which is ID Quantique, or IDQ. In April, SK Telecom and IDQ jointly developed a quantum virtual private network, or VPN technology, to be used by corporate clients in setting up protected networks using quantum cryptography. SK also won a number of pilot projects from the South Korean government to establish and operate quantum cryptography infrastructure in South Korea. A consortium led by SK Telecom has been selected for a state project to establish and operate a pilot infrastructure for quantum cryptography communication. The project is to secure the stability of emergency communication networks in key industrial facilities, such as nuclear power plants, and strengthen the protection of key data and personal information held by public institutions. SK said it would establish a heterogeneous quantum cryptography network of the Korea Advanced Research Network, or KOREN, a test network that supports feasibility and suitability verification of all technologies related to the construction of high-speed information and communication networks. KT, another South Korea telecommunications provider, is developing a quantum cryptography service in-house. Its quantum key distribution, or QKD model, was chosen by the South Korea Telecommunications Technology Association as the country's national standard. KT is also developing quantum hybrid technology that can implement quantum cryptography communication through smartphone apps. KT said its quantum hybrid technology will be applied in a range of 5G network services, including those for connected cars. LGU+ has been focusing on the development of post-quantum cryptography, or PQC technologies. The PQC, also called the quantum-resistant cryptography, uses mathematical algorithms that are secure against cryptographic attacks by quantum computers. LG applied the PQC technology last year on its optical communication networks for customers. It aims to expand the range of PQC applications in both private and public sectors. Countries are moving quickly to create applied research programs designed to accelerate progress in quantum technology development and ensure a strong domestic quantum technology community. In order for South Korea to develop its leading position, it must continue to invest in the creation of an enabling environment in academia, industry, and government for the knowledge, talent, and infrastructure needed by the field. Simultaneously, knowing that commercial applications are decades away, South Korea should anticipate the long game that will require continuity of effort, funding, preparation, and collaboration. Quantum computing poses both opportunities and risks to South Korea and the environment that it operates. Current research into quantum technologies and their applications is still nascent, leaving an incomplete understanding of how and when to prepare for future quantum computing breakthroughs. It's an opportunity for South Korea in quantum computing. That's all for this week's show. Follow me on Twitter or LinkedIn at Idea Explorer or my website ideaexplorer.com. Feel free to leave comments or suggestions about the show and tune in next week for more news and trends about Korea technology.